Did you know that the device you're using to watch this very explainer contains a highly fragile cocktail of elements sourced from some of the absolute most volatile regions on Earth? Well, welcome to this explainer. Today we're breaking down the SASB Sustainability Accounting Standard for electrical and electronic equipment. Honestly, you could just think of this as a survival guide for modern tech companies trying to navigate a wild, unpredictable global landscape. If you've ever wondered how the biggest electronics manufacturers measure, manage, and report the massive risks hidden deep inside their supply chains, you are in exactly the right place. Let's get into it.
Okay, let's set the stage. The SASB standards, which are now managed by the International Sustainability Standards Board, or ISSB, act as our main framework today. This framework strictly dictates how global electronics manufacturers have to report their sustainability and operational risks to investors. And listen, here's the kicker. This isn't just about PR or hitting some greenwashing goal. No way. This is about pure business survival. It's about identifying the very specific risks that could reasonably completely tank a company's cash flows or spike their cost of capital over the long term.
Here is our quick roadmap for today. Number 1, electronic sustainability standards. 2, the critical materials challenge. 3, supply chain vulnerabilities. 4, strategies for resiliency. And finally, 5, the broader sustainability picture.
Starting off with Section 1, Electronic Sustainability Standards.
We really need to grasp the sheer scale we're dealing with here. This is a massive, highly competitive industry operating on a global level. We're talking about companies manufacturing everything, from renewable energy equipment and smart grid tech, right down to industrial automation controls and everyday HVAC systems. To put that scale into perspective, a single company in this space might rely on tens of thousands of individual suppliers across the globe. That staggering reality makes managing their environmental impact, and especially their supply chains, an incredibly complex puzzle.
Moving right along to Section 2, the Critical Materials Challenge.
So what actually makes a material critical? Well, according to the standard, it's explicitly defined as a material that is both essential in use and subject to the risk of a supply restriction. In plain English, it's the unsubstitutable DNA of our modern devices that is at a super high risk of a supply squeeze. And here is the terrifying reality for these manufacturers. Without these specific materials, the assembly lines literally stop, full stop.
Imagine this as a high-stakes periodic table. First up, we've got our base critical elements, stuff like cobalt, tungsten, gallium, and graphite. It's actually kind of crazy when you think about it. These foundational elements are facing skyrocketing global demand, and not just from tech. Multiple booming industries need them at the exact same time. Naturally, this intense competition leads to wild, unpredictable price hikes and severe supply risks for anyone relying on them.
And then we have two other highly specialized buckets that these companies absolutely have to track. On one side, the platinum group metals, platinum, palladium, iridium. On the other side, the rare earth elements, like yttrium, scandium, and neodymium. What makes these elements so terrifying for a supply chain manager is that there are virtually no viable substitutes. If your component needs neodymium to function, you can't just swap it out for something cheaper. You either get it or you don't build the product.
Let's look at how that plays out in Section 3, supply chain vulnerabilities. It's a fascinating, double-edged sword of multi-layered risks. On one hand, you have the hard physical limits of the materials availability and the geopolitical hurdles to actually access them. On the other hand, you have the brutal price swings and the reputational risks that come with how they're mined. When a business relies on a material with strict physical limits, even a tiny hiccup in the supply chain isn't just a shipping delay. It's a massive blow that can completely alter the financial stability of the entire company.
Just picture a global map zooming in on these hotspots, places known for rare earth elements or heavy cobalt mining. These locations create massive, undeniable bottlenecks because these materials are sourced from only a handful of countries. This geographic concentration exposes tech companies to extreme geopolitical uncertainty. I mean, if just one host country changes its export policies or faces internal instability, the entire global electronic supply chain chokes, just like that.
So what do they do about it? Section 4, Strategies for Resiliency.
The sustainability standard outlines 4 main actionable defenses companies use and have to analyze in their disclosures. Step 1, diversification of suppliers. Basically, don't put all your eggs in one geopolitical basket. Step 2, stockpiling. Shout out to the warehouse stock managers out there, acting as the frontline defense by physically hoarding these strategic reserves. Step 3, investing in R&D to find substitute materials. And Step 4, pouring money into cutting-edge recycling tech to actually recover these critical elements from old, end-of-life products. Now, you might be wondering, doesn't reporting all this to investors give away their secret sauce to competitors? Actually, no. The standard clearly states that disclosure shouldn't compromise an entity's ability to maintain confidential information. So companies have to report their broad mitigation strategies and the general risks, but they are fully protected from revealing exact trade secrets or announcing, hey, we are literally running out of this exact metal right now, because that would obviously cause major competitive harm.
Finally, let's zoom out. Section 5, the broader sustainability picture. Sourcing these materials is actually just one piece of a much larger puzzle. Companies have to carefully balance energy and environment metrics against products and ethics. Environmentally, they are meticulously tracking things like the percentage of renewable grid electricity they use or the tons of hazardous waste they generate, stuff like heavy metals and wastewater sludge. But at the exact same time, they also have to disclose product safety recalls and any financial hits tied to anti-competitive behavior or ethical breaches. It's the whole shebang.
These companies are strictly graded on a scorecard of very specific operational metrics. They have to disclose the exact amount of hazardous waste they successfully recycle. They must report any monetary losses from product safety lawsuits. They're tracking the percentage of products containing toxic declarable substances. And on the flip side, they get to highlight revenue from energy-efficient, certified products. It's really a rigorous stress test of a company's entire ethical and environmental footprint.
Which leaves us with this final thought. We've seen exactly what goes into managing these massive electronics companies, right? From sourcing highly volatile rare earth elements in geopolitical hotspots, all the way to disclosing ethical business practices. The next time you pick up your phone or open your laptop, ask yourself, as our global reliance on these devices grows exponentially every single day, is the global supply chain truly resilient enough to survive the next critical materials squeeze? Or are we all just relying on a fragile house of cards? Thank you so much for joining me for this explainer, and keep questioning the world around you.